Welcome to my classroom. Today we will discuss about erosivity indices. Now here, before I discuss erosivity indices, we have two terms which we use in soil erosion topic. One is erosivity and another is erodibility. Now erosivity, basically, one is the causal agent, another is the agent which is being caused. So it's an interaction. Soil erosion is interaction between rainfall and soil. So the capability or capability of rain to cause erosion is called erosivity. And on the other hand, the susceptibility of soil to get eroded is called erodibility or soil erodibility. How erodible the soil is. Similarly, over here, how erosive the rainfall is, because rainfall could be low intensity, high intensity. So that determines the capacity of that rain to cause erosion, and we call that as erosivity. So it is ability. Now here let me explain you. Say this is storm 1, storm A, and it is causing erosion on a soil A. And then there is another storm, it is a bigger storm, this is storm 2 or storm B. So it is rainfall is there. So this is rain, and here the soil is getting eroded, and in this case erosion is say 50 tons per hectare, and this storm causes erosion of 20 tons per hectare. Same soil with two different storms, one is more erosive, it is causing more soil erosion, another is less erosive, it is causing less erosion. This is what we call as erosivity indices or erosivity index. Now the question is how to determine the erosivity of a particular area. For example, if I say if I have to plan some soil conservation measures in a particular area, so the first thing which will come to my mind is that what is the erosivity of the storm or rainfall taking place in that particular area. So in that case, we have certain erosivity indices. So different countries or at different places, these erosivity indices have been designed or planned. So basically, instead of it's very tricky, it's very difficult to measure the erosive power of rainfall, because it's not possible that every time at every place you go and measure the erosivity of the rainfall. Somewhere we have to go for an index. We have to use the properties of the rain to form an index, so that we get an idea that what is the erosive power of the rainfall. And there are many indices, different people, they have fabricated different indices, but the most commonly used indices are, number 1 is EI index, EI 30. Now EI 30, what is this? This is basically the product of energy of rainfall. Which energy? It is simply kinetic energy. Kinetic energy of rainfall multiplied by I 30. Now what is this I 30? I 30 is that suppose your rainfall has occurred over a period of 2 hours. So what we do is that we break that 2-hour period into 30 minutes intervals. So you have 4 30-minute intervals, and then we find out from the amount of rain that has fallen in each 30-minute interval and the maximum amount of rain in any 30-meter interval, that is I30. So, if I have to define I30, I30 is the maximum rainfall in any 30-minute rain interval. That is called I30. And this is generally, if you might have studied, we have recording type of rain gauge, and in recording type of rain gauge, we have this type of chart. This chart here has been divided into, say, 8 hours, then 10 hours, then again 12 hours, then 14. Similarly, this is basically a 24-hour chart. Now, rain starts at 8 hours. So, this goes like this, then it falls, then again it goes like this, falls, this, like this. Now, what we have to do is that we will divide, this is now 2-hour period. So, 30, 30, 30 and 30, and then again 30, 30, 30 and 30, then again 4, 30, 30, 30, like this. So, what we will be doing, so here you can also do it 30, 30 something. So, we will now find out during this 30-minute interval what is the amount of rain. So, this is amount of, here generally we take rainfall is from 0 to 10 millimeters. So, at every 2 millimeter you can say it is 5 millimeter. So, this is how you can find. Then for next 30, this is the amount of rainfall. Now, this is basically the amount of rainfall between this 30-minute period. So, this will be the amount of rainfall, this much. Similarly, for next, now for this rainfall is here. So, this will be the amount of rainfall A, here this will be A, here this will be A, like this. So, ultimately you will find out the amount of rainfall in each 30-minute interval, and the maximum amount, say, comes over here, this one. So, it is, say, from 8:40 to, sorry, it should be 8:30 to 9 hours, and rain here is the maximum, say we have 20 millimeter of rainfall. So, then I30 will be 20, because this has occurred in 30 minutes. So, intensity is basically the amount of rainfall per hour. So, it will be then 40 millimeter per hour. So, this is I30, maximum amount of rainfall during any 30-minute interval we take over here. Product, then we find out the kinetic energy of the rainfall. I will just now show how to calculate the kinetic energy, and the product of the two will give us an index EI30. So, we can then map this EI30 for different places in a particular state, in a particular country. We can have a country wise map that, okay, at these different places we have this type of erosivity. Then we can. Second is kinetic energy greater than 25. Now, what does this mean? Basically, this 25 is intensity, 25 millimeter per hour, if I say millimeter per hour. Now, the hypothesis is that the rain at low intensities is non-erosive, it does not cause any erosion. The low intensity rain does not cause any erosion. Even if some rain is there, low intensity rain, this is non-erosive. And if some splash, when rain falls on the soil, some splash erosion could be there. Particles may get splashed in different directions because you know how splash erosion occurs. When this raindrop, it strikes the soil, it breaks down the aggregates, then particles they splash in different directions. This is what we call as splash erosion. Now, these particles, they have been detached and thrown away at some distance, but there is not sufficient runoff to carry these. And you know, soil erosion is the process, this process is completed only when there is detachment plus transportation of the particle. Of course, detachment is there, maybe very small detachment, because when you have low intensity rain, its kinetic energy will also be low. So, low kinetic energy means breakdown of aggregates will be very small, and whatever aggregate breakdown has taken place, particles splashed in the air, thrown away at some distance, but there is not sufficient runoff to carry these particles. So, that means soil erosion will not be there. So, if soil erosion will not be there, then we come to this conclusion that low intensity rain is not erosive, it does not cause erosion. Then you know, experiments were carried out in different parts by the scientists, and they came to the conclusion that 25 millimeter per hour intensity, this is basically the threshold value. Threshold value between erosive and non-erosive. So, that means we have so one is I intensity of 25 millimeter per hour. This determines that below this 25 millimeter per hour, the rain which is occurring at an intensity less than 25 millimeter per hour, this is non-erosive. Whereas the rain which is occurring at an intensity more than 25 per hour, that is erosive. It has more capacity to cause erosion. So, based on this, what we find out, you know, the index, that is Ke greater than 25 mm per hour. We calculate the kinetic energy, you know, kinetic energy 1/2 mv square. So, simply whatever rain amount is there with intensity greater than 25 millimeter per hour, that index is called as Ke greater than 25. Then third index is AIM. This. Now, this particular index was given by Dr. Ratan Lal in Nigeria, because he was carrying out the experiments in Nigeria, and this index basically it best correlated with soil erosion in that particular area, that is Nigeria. So, what does this mean? It is the product of amount of rain multiplied by, so product of amount of rainfall and maximum 15-minute rain intensity. So, earlier in EI30, what we did, that we calculated the rain amount in 30-minute intervals, but here we have to calculate the rain amount in 15-minute intervals. So, if this is the 15-minute interval, so we will find out the amount and maximum intensity during any 50-minute interval. that is to be multiplied by the amount of rain in that particular interval. The product of the two gives us an index AIM. So, this index best correlated with soil erosion. In Nigeria. In some parts of India, we have seen that EI 15 that gives a better index instead of AIM or KE greater than 25 or EI 30. Because we have the tropical rains over here. For tropical rains, EI 15 gave us the best results. So, this is how these are some most three popular erosivity indices which we use for calculation of or design of soil and water conservation measures, because design of soil water conservation measures will be possible only if we do have an idea about the kinetic energy over there. So, now we will take an example how to calculate these indices. So, that example will be somehow like this. Say we do have rain data is with you. From this chart you find out the rain data, and here you have the amount of, we can make different classes of intensity, rain intensity, say starting from 0 to 25 millimeter per hour, 25 to 50, 50 to 75 and more than 75 millimeter per hour. Then from the rain gauge chart we will find out the amount of rain. So, then second column is rain amount. So, one thing is very much clear that for calculating the erosivity indices you should have the data from recording rain gauge, and that data is available on the recording rain gauge chart. You have to analyze that chart, find out, make these classes for each intensity level 0 to 25, 25 to 50, and so that we will calculate the rain amount. This will be in millimeters, and say it is 30 over here, 25 over here, 15 and 10. So, this is the amount of rainfall in different intensity levels or classes. Then we will calculate energy, and here the energy has been calculated with an empirical relation. That relation is 11.9 plus 8.7 log of I. I is intensity. So, we have to take this log of, say, whatever intensity you have. We will take over here the mid value of the intensity, 0 to 25, that means 12.5, 25 to 50, 37.5, like that, and then use I over here, take its log, multiply by this and this energy. Its units are joules per square meter, joules per square meter per millimeter of rainfall. So, this is how we calculate the energy, and this energy calculated over here, it comes out to be 22, 26, 28 and 28.3. Then we will find out the total energy. Total energy, why? Because this is energy per joules per square meter per millimeter of rainfall. So, we have 30 millimeter. So, multiply these two. So, you get now 660, and here the units will be now joules per square meter. So, 660, this comes out to be 650, then 420, then 283. So, this is now total energy for 0 to 25 millimeter per hour class. This is total energy for this class similarly. Then we will add these up. This comes out to be 2013 joules per square meter. Now, this is total energy of the rainstorm, because your rainstorm occurred like this. So, now total energy of rainstorm. So, this is this one. Now, we have to calculate EI 30. So, here let me clean this. So, now EI 30 will be energy, total energy multiplied. Now, you have to take this energy, that is total energy is your 2013 joules per square meter. This is to be multiplied by I 30, and say I 30 over here, whatever I 30 is there, you multiply. Now, I 30 is again to be calculated from the rainfall chart. You make 30-minute intervals for the whole of the storm, and then find out the maximum amount of rain in any 30-minute interval, that is to be multiplied over here, and this is how you get EI 30. I hope that is clear. Then coming to second index, that is kinetic energy greater than 25 millimeter per hour. This index, simply you ignore the first one, you add up the total energy of this. So, here I should say total energy of rain with more than 25 millimeter per hour. So, you will exclude this. So, you will come out with the value, it is 1337 joules per square meter. So, this will be 1337 joules per square meter. This is how simply from the same data you can get. And AI, AIM, that's all. You have to calculate the amount of rainfall in 50-minute period, then multiplied by intensity, maximum intensity of in any 15-minute period. Then comes what is the application of this. I have already discussed the application of the erosivity indices. Why do we need to calculate the erosivity indices? So, first I said you that the most important thing is whenever you have to go for planning of soil and water conservation in a particular area, the first demand from your side should be that what is the amount of erosivity, what is the erosivity value over here. So, I am using this electronic board for the first time. So, maybe I am not so expert in rubbing the things. So, maybe I am wasting some time, but anyhow this is otherwise this recording room is very good. So, I prefer to come over here, but anyhow. Okay. Now, applications of erosivity indices or erosivity simply. So, first thing is for designing of soil and water conservation measures, because it is always very important that while designing soil and water conservation measures, you should be clear about that what is the erosivity level, so that you can have an idea that to what extent the erosion can take place. So, your soil conservation measures should neither be under designed nor over designed. So, these should be neither under designed or over designed, because if these are under designed, then instead of checking the soil erosion, it may enhance the rate of soil erosion, and if these are over designed, that will not be economical for you. You will be spending too much of money just for a small amount of erosion to take place. So, it is always better to have an idea about the erosivity of that particular area. So, this is its first application. And similarly, we can have the erosivity maps, as I said, in every country. So, then in different parts of the country, you can have that, okay, this part has this much of erosivity, this much of erosivity. You can have erosivity contours also. And then for any place in your country, you can design soil and water conservation measures depending upon the value of erosivity. Second is in erosion research. Research on soil erosion, most of the research of soil erosion, it is conducted under simulated rainfall conditions. So, I mean, to artificial rainfall is created. So, now when you have to go for artificial rainfall simulation, we must have an idea that I am going to conduct this research for this particular area. So, whatever simulation of rain I have to do, its erosivity should be similar to that of actual erosivity which is taking place. So, erosivity of simulated rain should be similar to that of actual rain erosivity. Instead of actual, you can write as real rain erosivity also. Only then your experiment will be applicable for that particular area. So, these are the two applications over here. Then one thing which I forgot to tell you, that if this is the index, this index KE20 more than 25, this is generally applicable in tropical areas. And for temperate regions, they suggest to take this threshold value as 10 millimeter per hour. This is for temperate regions. Now, here I will just give you an idea that what is the difference of difference between temperate and tropical region, because you should know those differences. And generally, if I say that temperate regions are colder as compared to the tropical regions, temperature there remains low. So, in that case, some of the differences between the two are number one is the tropical rains. So, here sorry, tropical rains and temperate rains. The major difference is that rain intensity is higher here, and here rain intensity is lower. To go in more details, in tropical rains, 60% of rain falls at very high intensity, occurs at intensity more than 25 millimeter per hour. Only 40% of the rain occurs at intensity less than 25 millimeter of rain. On the other hand, in temperate areas, here 90% of the rain occurs with intensity less than 25 millimeter per hour, and only 10% of the rain it occurs at the intensity more than 25 millimeter per hour. So this is difference between tropical and temperate rains. Here, so this is difference 1. Difference 2 is total amount of rain is always higher. We have more amount of rain is higher in tropical than in tropical temperate regions. Total rain amount is lower. Third difference is average intensity. As I said, average intensity is higher and here average intensity is lower. So that means in temperate regions we don't expect soil erosion to be too high as compared to tropical regions, because high intensity means high erosivity of the rainfall and higher erosion. So I think that's all. Thank you very much for today.